Okay, we're in A2 Unit 1 Lesson 3, and this is about solving equations, proportions, and literal equations. I know a lot of this is going to be a review, but remember, at this level, when we review something, even if you're not learning something new, you are supposed to be building your speed and your consistency. So you still need to practice, all right? First of all, when we solve equations, now an equation has an equal sign. We have one rule, and that rule is do the same thing to each side. Keep it balanced. That's your only rule. Now, we do have a set of best practices, and if you do these most of the time, then they're going to help keep you from making a mess, and they're going to help you work the problem faster and more consistently. So the thing is, you don't want to wing it, because when you just start trying to look at a problem and go for whatever you want to, that's when you wind up with a mess. So here are your best practices. The first thing you always want to do, well, the first thing that's best to do is to get rid of fractions or decimals. And you do that by multiplying by a common denominator or multiplying by a 10 or a factor or multiple of 10 to get rid of a decimal. All right, the next thing is to simplify each side. An equation has two sides, one on each side of the equal sign. Look at each one separately and use PEMDAS. Simplify anything that you can. Now, the next thing is to get rid of all but one variable term. At this point, if you have a variable term on both sides, you need to get rid of one of them. Then we're going to get rid of any numbers added to or subtracted from the variable term, and then we get rid of any numbers multiplied by or divided into the variable. Now, like I said, these are just best practices. So there are things that as you gain experience, you're going to see there's times to deviate from this. So let's just get some examples and dive in. Okay, let's look at number 1. Now remember, I am going down that list of best practices in my head every time I work a problem. You're going to skip steps a lot of time, but still go through them. And I made a shortened version of them over there. So like for step 1, get rid of fractions or decimals. There aren't any, so I would skip that. Now I am to the point where I need to look at each side and see if I can simplify. This one has parentheses, so I can simplify by distributing what's in here. 6n plus 30 equals negative 18. Now I only have one variable term, so I'm not going to do step 3. Next, I need to get rid of the number added to or subtracted from. 30 has been added, so I am going to subtract it from each side. 6n equals. Now, negative minus a negative, you add and keep the sign. Or a negative minus a number, you add and keep the sign. So this is going to be negative 48. Divide both sides by 6. So n is equal to negative 8. Okay, let's go to number 2. Okay, number 2, so the first thing I'm going to do is get rid of my fraction. I just have this one denominator, so if I multiply by that on both sides, that's going to get rid of it. Here it cancels out, so I have 3 times 5 minus 3x left equals negative 15 times negative 4 is going to be positive 60. All right, now I'm ready to simplify, so I'm going to distribute. 3 times 5 is 15 minus 9x equals 60. Now, look where this is your variable term, and it's in, it's in an unusual place. Usually your variable term's over here, but remember, your best practices, they refer to things by how they are joined to the variable term, not by what position they're in the problem. So the next thing I want to do is get rid of any numbers that are joined to my variable term by addition subtraction. This 15 is the join to it, but it's joined by the sign in front of it, which is a positive sign. So to get rid of it, I have to subtract it. Now what I have left is 9x. This minus sign belongs to the number behind it, so it belongs to 9x. And 60 minus 15 is 45. Divide both sides by negative 9, and x is equal to negative 5. Okay, here's number 3. 2 times 2 minus 7y minus 5 equals negative 29. And it'd be a really good idea as we go through these problems, if you feel pretty comfortable with it, pause the video and work the problem and see if you get the same answer I did. All right, we are down to step 2. There's no fractions or decimals to get rid of, so we're going to look at each side and see if we can simplify. The presence of parentheses always tells you that there's something you can do. So 2 times 2 is 4, and 2 times negative 7y is minus 14y. Minus 5 equals negative 29. Now we're going to simplify some more because we have these two constants. 4 minus 5 leaves you with minus 1. All right, now we're going to add 1 to each side. So I have negative 14y is equal to negative 28. Divide both sides by negative 14. And y is equal to positive 2 because negative divided by negative is positive. Okay, let's look at problem number 4. Now, this one has a lot of fractions in it, and this is a prime example of when sometimes you don't have to do things in order of best practices. Because I'm looking at these 3 denominators, and if I get a common denominator and then distribute it through there, my numbers are going to get really big. But I also notice that when I start comparing these, there are some common factors that would let me reduce this down. So what I'm going to do on this one is I am going to distribute 15/16 into here, and I'm going to multiply that. So negative 16 is not going to change on this step. And I'm going to come over here and do the multiplication. Negative 15/16, your answer is obviously going to be negative, but let's do times 4/5 and watch what happens. Your 5 can cancel with the 15 and give you 3. 4 will go into 16 4 times, so now you really only have negative 3/4 Q. So that worked out real well. Now a negative times a positive is going to be minus again. Let me come over here and do 15/16 times 32/3. Let's go ahead and reduce. 16 will go into 32 2 times. 3 will go into 15 5 times. And 5 times 2 is 10. So this is one time when just going ahead and working with the fractions was a little bit easier than finding a common denominator. All right, now we're back to our best practices. I'm going to get rid of, and still I'm not going to fool with this fraction right now. I'm going to go ahead and get rid of this 10 by adding 10 to each side. So now what I have is negative 6 is equal to negative 3/4 Q. Okay, options here. You can do this in one step or you can do this in 2 steps. Q has been multiplied by 3. 3/4 Q is actually 3Q over 4. You understand that? So you can multiply by the reciprocal. I could multiply both sides by 4/3, and that would get rid of it. Or I can do it in 2 steps, which I'll do. I'm going to multiply by the denominator first. So that's going to be 4 on each side. So now I have negative 24 is equal to, these 4's cancel, so I get negative 3Q. Then divide both sides by 3, so Q is equal to positive 8. Okay, so here's number 5, and once again, if you're feeling pretty comfortable, go ahead and pause the video, try to work it yourself and see if you get the right answer. All right, I'm working my way down my best practices, and I get to the part where it says get rid of all but one variable term. Well, I have 10 and 6. So I'm going to choose to get rid of the 6a because it's negative, and whatever I do to one side, I have to do to the other. So here we go. All right, this is going to give me 16a minus 7 equals 21. Now let's add 7 to each side. 16a is equal to 28. Divide both sides by 16. So I get a equals 28 over 16, but let's reduce them both. 4 will go into each one, so you get 7/4. Okay, here's number 6. We got some fractions again, and I see that I have a 6 and a 3 for a denominator, so this is kind of going to be a prime candidate for let's just go ahead and get rid of those fractions. The greatest common factor, or the least common multiple between 6 and 3 is going to be 6. So I'm going to multiply both sides of this equation by 6. Okay? Now, you have to understand, over here, these two numbers are already factors. So when I just multiply the side by 6, it's going to look a little bit differently over here than it is over here. All right, when I multiply 6 times 5, 6, those two cancel out, so I have 5W. And then 6 times plus 21 is going to give me a positive 126. All right, over here, I have 3 factors. Now you have to remember, when you multiply factors together, you only do them once. Like if I had 2 times 3 times 5, I'm just going to multiply the 2 times the 3 and get 6, and then the 6 times the 5. I'm not going to multiply 2 times 3 and 2 times 5. It doesn't work like that. So what I'm going to do here is I'm going to multiply negative 1/3 times positive 6, and that's going to give me negative 2, and then I still have the 2W minus 9. All right, for my next step, I'm going to distribute that into there. Now, nothing over here is going to change. So I have negative 4W plus 18. I know that was kind of messy, but, you know, it wasn't too bad. Now, let's go ahead and work with our best practices. I'm going to get rid of one of my variable terms. Since 4 is negative, I'm going to add 4W to each side, and that's going to give me 9W plus 126 is equal to 18. So then I'll subtract 126 from each side, so I get 9W is equal to negative 108, and then divide both sides by 9, so W is equal to negative 12. And that is negative 12. So here's number 7, and I'm going down my list. I'm going to stop at number 2 because I see parentheses, and I know that means I need to simplify. So I'm going to distribute. That's going to give me negative 40 minus 30, actually that's 40p, equals 5 minus 5p. Going on down. I have a negative 40p and a minus 5p, so I've got to get rid of one. I'm going to add the 40p to each side, so then they'll be positive. Now I have negative 30 is equal to 5 plus 35p. Then subtract 5 from each side. So negative 35 is equal to 35p. Divide both sides by 35, and p is equal to negative 1. Okay, here's number 8. So once again, if you're feeling confident, go ahead and pause the video and see if you can work it, and I will go ahead. Now, there are no fractions decimals, so I'm going to number 2. I see these parentheses on each side, so let's get rid of those first. Now here I have 16 minus this set of parentheses. So what I'm going to distribute is just it's actually an understood negative 1 or minus 1. So that's what's going to get distributed, and it's going to make that minus 7m and minus 3. I'm not distributing the 16, just the negative. All right, over here, when I distribute, this is 8 times the parentheses. So that's why I distribute the number. So 8 minus 8m. Okay, let's come back over here. There's still some simplifying to be done. I have 2 constants. So I can do 16 minus 3 gives me 13 minus 7m is equal to 8 minus 8m. All right, I have a minus 7m and a minus 8m. I need to get rid of one of those. That's step 3. So I'm going to, since they're both minus, I've got to add either way. I'm going to choose to add the larger one. That way it's going to get rid of a negative. So now 13 minus 7 plus 8 just gives you plus 1m, and you don't have to put the 1. These two cancel, so I have 8. Now get rid of the 13, subtract 13 from each side. M is equal to negative 5. Okay, number 9, here's the problem. We do have this denominator down here, so let's just get rid of that. We're going to multiply all the way through by 2. So when I multiply this side by 2 and this side by 2, all right, these 2's are just going to cancel out. So I have all this stuff left up here in the numerator with no change. Now here, let's go ahead and distribute while we're at it. 2 times 3x is 6x plus 2. Okay, then I look again and I say, well, I've got this set of parentheses here, so let me get rid of it by distributing what's outside. And what's outside is this minus, and it's understood to be a 1. So when I distribute that, that's going to be minus x and plus 9. Okay, still looking over here at the left, I can still simplify. So I'm still on step 2. 10x minus x is 9x, and plus 17 plus 9 is plus 26. Now I have two variable terms, one on either side, so I got to get rid of one of them. They're both positive, so I'm going to choose to subtract the smaller one. That keeps me from creating a negative. 9x minus 6x is 3x, plus 26 is equal to 2. Now I'm going to subtract 26 from each side. So 3x is equal to negative 24. Divide both sides by 3, and you get x is equal to negative 8. Okay, here's number 10, and this would be an excellent one for you to give a try at this first. So pause the video and see what you can do with it, and then check back. There are many different ways to work this one, and as far as best practices go, I'm kind of going to jump around for this one. All right, what I see here is I'm going to separate these with parentheses, so I can say I've got 2 factors here and 2 factors here. All these fractions, they don't really bother, the half and the fourth doesn't bother me as much as this eighth does. So I'm kind of going to whittle at this one. I'm going to get rid of the 8 first. So I'm going to multiply this side by 8 and this side by 8. Okay? When I multiply here, this is going to give me 9 times 4 minus 1/2 a. Remember, you only multiply this 8 times one of these factors. I could distribute it in here, or I can multiply it times this one. Same thing here. I could take this 8 and I can multiply it into that one and then do it times 3, or I can multiply the 8 times 3, which is what I'm going to do. So now I have 24 is equal to 1/4 a plus 5/2. All right, so now let's just distribute. 9 times 4 is going to be 36, and then I'm going to have 9 over 2a, which is not nice, but we can work with it. Now when you multiply 24 times 1/4, remember this is over 1. 4 goes into 24 6 times. So multiplying 6 times 1/4 a gives me 6a. Now 24 times 5/2, it's over 1. The 2 goes into 24 12 times, and then 12 times 5 is 60. So there's what you have, which is not great, but it's a lot better than it was. Now I'm going to choose to go ahead and get rid of the last remaining fraction. Since it's just a 2, I'm just going to multiply everything in here by 2. 36 times 2 is 72. 2 times this 9/2, the 2's cancel out, so I get 9a. 2 times 6a is 12a, and 2 times 60 is 120. All right, now get rid of extra variables. So I'm going to add 9a to each side, and that's going to give me 72. Those cancel out. 12 plus 9 is 21a. plus 120. Now I'll subtract 120 from each side. 72 minus 120 is negative 48 equals 21a. You divide both sides by 21. So coming over here, my last little remaining room, I've got a equals negative 48 over 21. Well, 3 goes into both of those, so my reduced answer is going to be negative 16 over 7. Is that what you got? Okay, on your guided notes, number 11 and 12 say special cases. So let's, be on our toes and let's see, why are these special? What happens here? All right, we're going to use our best practices. There's no fractions or decimals. Simplify. I see the parentheses. I know that always means go there. So 1 plus 3c is equal to 5 minus 5c plus 8c. All right, I can still simplify here. See, I'm still using my best practices. All right, minus 5 plus 8 is going to give me plus 3c. My next step says get rid of extra variable terms. This is where people start trying to wing it, like I said, and they get messed up. Do what your best practices say. I've got a 3c on each side, so I got to get rid of one of them. So I subtract 3c. Whatever I do to one side, I just have to do to the other, even if it looks wonky. All right, what I wind up with is 1 equals 5. That is not a true statement. That is false. So what that means is there is no solution to this equation. There is no answer. So that's the empty set, the null set, no solution. Now let's look at number 12. Okay, so number 12, no fractions or decimals. There are parentheses here, so let's simplify that side first. This left side is not going to change. Negative 8 times x is negative 8x. And negative 8 times 5 is going to be, negative 5 is going to be positive 40. Okay, now, doing what I know to do, get rid of one of these variable terms. I'll get rid of this one. To get rid of it, I'm going to add 8x. Whatever I do here, I have to do to the other side. I don't care how it looks. So now, what you wind up with is 40 equals 40. This is different from number 11 because this is a true statement. Number 11 was not a true statement, it was false. So if you come up with a true statement, and it can be two numbers or a number equal to itself, it could just be x equals x. That's still a true statement. So what you have here, you can use the big pretty R, the fancy R, or you can just say all real numbers. All of these are the correct answer, and that means anything you put in here is going to work, any number. Okay, number 13, and this is a proportion. So first of all, you have to be able to recognize a proportion. A proportion is when you have one fraction on each side with an equal sign in the middle. It can't be a fraction plus a number. It has to be one single fraction on each side. Then you can do what you want to do, cross multiply. All right, that's not the only way to solve a proportion, but it is the easier way. So when we cross multiply, I'm going to multiply 5 times x plus 4 equals 2 times 40. Now you're ready to solve using your best practices. So you've got 5x plus 20 is equal to 80. Subtract 20 from each side. And we get 5x is equal to 60. Divide both sides by 5. And x is equal to 12. Okay, for number 14, we look at it and we do have a proportion again. See, I've got one fraction bar. One fraction is all there is on either side. So let's cross multiply top to bottom. So I'm going to do 10 times 2x minus 8 equals, all right, bottom to top, and I'll just put the 8 in front. It doesn't matter when you're multiplying which one comes first. All right, when I distribute here, I'm going to get 20x minus 80 is equal to 40x minus 72. I'm doing my best practices. All right, I need to get rid of either 20x or 40x. They're both positive, so I'm going to choose the smaller one to subtract. So I'll subtract 20x from each side. These two cancel out, so now I have negative 80 over here is equal to 20x minus 72. And then we'll add 72 to each side. So this is going to be negative 8 is equal to 20x. Divide both sides by 20. And x is equal to, all right, negative 8 over 20 will reduce, 4 will go into both of those numbers. So that's going to be negative 2/5. Okay, the next section that we're going to look at is called literal equations. What that means is you're going to solve the equation for a certain letter, but you're not going to be getting an answer. You are just manipulating and reformatting the equation. So for example, number 15, we want to solve this one for pi. That means I want to get the pi all by itself. So in this equation, pi is actually my variable. I want it all alone. Well, what's been attached to pi? The 2 and the r. They've been attached by what operation? Multiplication. What undoes multiplication? Division. So I'm going to divide that, and then to keep it balanced, I'm going to divide the other side. Now over here, these two cancel out, so you get c over 2r is equal to pi. And sometimes you might have to rewrite that to put the variable that you are solving for on the left. That just depends on your instructor, but either one of these is correct. Let's look at number 16. Okay, on number 16, here's our problem, and we want to solve it for p. Now I do want to call your attention to the fact capital A is not equal to little a. Those are two separate things, okay? So we're not going to be able to let them cancel or interact or whatever else. But we're going to get rid of everything that's attached to the p. I see this 1/2. How can you get rid of a half? Well, multiply it. Multiply everything on this side by 2. Keep it balanced over here. So what we have at this point is 2a. The 1/2 times 2 is 1. So we have AP. Now we're solving for P. What's attached to P? The A is by multiplication, so I'm going to divide. Do the same thing to the other side. Now I have 2 capital A over lowercase a is equal to P, which you might want to rewrite to have the indicated variable on the left. I don't know, but either way. Okay, number 17, here's our problem. We want to solve it for B. Well, here is the B. So I got to get rid of everything attached to it. First, it's this C that's been divided over here. So I'm going to get rid of it. Whatever I do to one side, I have to do to the other. So now these cancel, and I have A plus B is equal to 5C. All right, now what's attached to the B? That A is. So I'm going to subtract A from each side, and I get B is equal to 5C minus A. Okay, number 18, 3x minus 3y is equal to 24, and I want to solve that for x. Several different ways you could go about this. You could go ahead and get your greatest common factor out, and that kind of gets things away from the x, but I'm just going to do this the plain way, I guess. I see x here. The first thing I want to get rid of is stuff that's been added to or subtracted from it. So I'm going to get rid of that. Whatever I do to one side, I have to do to the other. And that's a y. All right, so now I have 3x is equal to 3y plus 24. Then I need to get rid of the 3. So I'm going to divide all the way through by 3. All right, these cancel out and I have x. Now 3 over 3 makes 1, so you have y plus, and 24 divided by 3 is 8. Okay, here's number 19. Here's our equation, and we want to solve it for v. Now v is buried inside the parentheses here. You could distribute the 1/2 and then work with it, but 1/2 is pretty easy to get rid of, so I'm just going to multiply this side by 2. That cancels both of those out, and I get W plus V left here, and I don't even have to put that in parentheses anymore. Now, what do I have to do over here to keep it balanced? Well, I have to multiply this by 2. So now I have 14W. All right, remember I'm solving for V. What's attached to the V? The W. So I'm going to subtract W from each side. So now 13W is equal to V. And like I said, you can flip that to put that on the left and have V equals 13W. Last one, number 20. Here we go, and we are solving this one for N. So there it is. All right, let's go to the outside first. This has been multiplied by 180, so I'm just going to divide by 180 to cancel it. And whatever I do to one side, I have to do to the other. So now what I have is S over 180 is equal to N minus 2. All right, if I'm solving for N, I'm just going to add 2. Whatever I do to one side, I have to do to the other. So I have S over 180 plus 2 is equal to N. And yes, you could flip that and put your N on the left, okay? All right, you should be ready to practice on your practice papers, and you did a fantastic job. This is a really long lesson, so good job for hanging in there, and I'll see you later.